All right, what's up, guys? We are live for our Wednesday morning live stream, and we are coming to you with a continuation of the SAT Khan Academy problems. Now, first of all, I'm just going to check my audio, make sure everything is running smoothly as I like to do. And if everything is running smoothly, then we will get going. Here we go. I always like to check out my phone as an extra backup device. The issues that I've had before have been with audio. Audio's going fine. All right, so we are off and running this morning. Now, we've gone through all the Khan Academy full-length SATs, and that I'm so excited about that. That was a big project of mine. It took me a while, but 1 through 8 has all the math sections have been solved. Now we're going to go back and recanvas the practice problems, which I've already gone through, but I've only gone through the first 5 out of each section. So I believe there's about four sets of 5 problems in each section with increasing difficulty as we go farther along. So I'm going to choose, now I'm going through this next wave of questions. The difficulty level will increase. And today we're doing interpreting linear functions, and which are a lot of word problems. So we're going to start there, and we're going to continue this week by week. So hopefully this is helpful for you guys. And if you guys have any questions or comments, please just email me, and make sure to subscribe to the channel today if you want more up-to-date information on the SAT math problems, and of course our math music videos, all the other good content. The podcast will soon be coming all up on YouTube as well. So let's do it. Let's jump in right into it. Here we go. So we got Khan Academy all set up here. We're going to jump into interpreting linear functions. All right, so you see it's like this, right? We'll get 5 questions. They'll tell us in the upper left-hand corner if it's calculator or not. This is a non-calculator section. So it says the total cost, C in dollars, to produce B books is given by the equation above. What is the meaning of 1.5 in this equation? So basically, the 1.5, if we think about it as a linear function, it's the slope. It's basically what's multiplying by the number of books. Now we can assume that this is some fixed cost because it's just a constant. So what is this? Well, think about it. If number of books equals 1, it's just going to be 1.5, right? If it's 2, it's going to be 2 times 1.5, which is 3. So what does that tell us? As the number of books increments by 1, the overall cost increments by $1.50 or 1.5, which tells me that this looks like the price per cost of books. Right, we have 10 books now, all of a sudden it's $15. So I'm going to say it costs an extra $1.50 for each book produced, like the cost of each book. The rest of these flat fee, no way, because it'll be only if it's a constant. All right, let's go on to the next one. Jing is making homemade peanut butter. The equation above shows the amount of peanut butter yielded B in cups for A cups of peanuts. Okay, so this, and let me write it over here. B equals 0.55A. So this is the amount of PB, and this is cups of peanuts. So before we even read the answers, let's look at this problem a little bit. It looks like if we put in a certain number of cups of peanuts, let's say 2 cups, we're going to yield a smaller amount of peanut butter, right? Because if we put 2 times 0.55, that's going to equal 1.1. So that's 1.1. So for 2 cups, we're going to get 1.1. For like 10 cups, it looks like we're going to get 5.5 cups of peanut butter, so on and so forth. All right, so so now it's asking what percentage of the volume of peanuts is lost when processing them into peanut butter. One way we could do this, if you want to just do a quick calculation, I mean, you can see that 0.55 is equivalent to 55%. So we could say that 55% of this amount is going in here. So what's lost? Then what's lost is 45%. If you're not totally confident with recognizing that that's a decimal equivalent to a percentage, you could also do one quick example and be like, all right, well, out of 2 pounds, we lost 0.9, right? And then you could set this up equal to a percentage proportion and solve it that way. But anyways, we're losing 45%. This is the one that might trip you up, 0.45%. All right, let's go on to the next problem. A store is having a sale on every item purchased. Okay, let's see. P equals 0.7C. Irina decides to take advantage of the sale and purchases a sweater. The equation that gives the after sale price is this, where of Irina sorted with original cost of C. Okay, so originally cost, whatever C is, the new sales price is P. What percent off the original cost did she save? So she's paying 0.7. This is, if we convert this to a percentage, it's 70%. So she's only paying 70%. She's not taking 70% off. She's only paying 70%, which means she's saving 30%, like this. All right. Let's move on to number 4. A print shop copies and prints documents in large volumes for its customers. For a particular copy machine, the equation above gives the amount of toner, T, in grams left after making C copies. So look, here's our constant. This is always our starting point. So it's like we have 1,200 grams of toner to start with is what it looks like. And then we make a number of copies. So how many grams of toner are used per copy? Again, this is the number of copies. This is per copy. This is the change for every one copy. So it's literally as easy as identifying that and plugging it in. You basically only have 2 options to choose from, right? Where you have 0.06 or you have 1,200. So I'm going to say 0.06. And that's good. Final question, number 5. Antoine bikes part of the way on a 22-mile trail and walks the rest of the way. If he spends B hours biking and W hours walking... Okay, let's get this equation up here first. 16B hours bike. Oops, bike hours walk. If he spends B hours biking and W hours walking, the trip is modeled by the equation shown above. What is the meaning of 16B? All right, now this gets a little trickier, right? We need to think about what's happening. So remember, this whole thing is equaling distance. If that's the case, then this side is also going to be some value of distance. If we just look at the B value, it's hours. Just look at the W value, it's hours. And now they don't tell us what this 16 means, but we know that basically these two quantities have to be some form of measurement. And what makes sense is that this whole quantity right here is the, what is this, in miles, right? Miles biked. And this is the miles walked. What that 16 probably means is he bikes 16 miles per hour. What that 3.5 means is probably he walks 3.5 miles per hour. But the good thing about the SAT is they usually don't use numbers that are nonsensical. So for example, 16 miles per hour biking is actually a relatively reasonable speed. That makes sense. Walking 3.5 miles per hour is a reasonable rate. So you can kind of get a feeling from that as well that, all right, this is probably what they mean. So we say Anton travels a total. I don't think that's it. He travels a total of 22 miles, but that's kind of close. At least they're talking about miles. Bikes for a total of, no, remember I said the B is the hours, not 16B. Antoine bikes for 16B miles. That's the one. And then last, Antoine rides his bike at an average speed of 16B miles per hour. Not 16B, but 16 miles per hour. And that's correct. Okay, so that is it for interpreting linear functions. And again, this is the second round of problems. So we're going to continue this every week. Like I said, if you guys have any questions or comments, please place them in the questions or comments below. If you want more of this awesome information, then definitely subscribe to the channel. It would be amazing. Check us out at scalarlearning.com as well. If you sign up there for our mailing list, you'll not only get our mailing list, which gives you amazing, up-to-date education information on all fronts, but you also get access to our free multiplication course, which is $20. You'll get it for free. Thank you guys so much for joining. Have an awesome rest of your day and week.